All right, let's do this. Let's get it done. What should have happened, my friends? Let's try and see if we can get it done, ladies and gentlemen. So, first of all, we have the famous Planck formula, which happens to be row your boat of the frequency W. We're going to start having this problem with focusing again. Man, we've got to work on periscope. Come on, you can do it. You can focus. There we go. Equals. Okay. Now I'm going to tell you what this formula is. This is the formula for the black body spectrum, and I'll tell you what that means in a sec. So H bar, as you guys know, is the pixel size of the universe dropped over 2 pi, the reduced one. Omega 3, which is what we've got some sort of angular frequency, we could call it that, over pi squared c cubed, which is the speed of light, cubed, outside of e, which is always our magic mathematical number, to the power of h bar w, which is pixel size frequency, over over the Boltzmann constant times the temperature. Ow, can barely see out here. Minus 1. Alright, what the hell is this formula? This is the famous Planck formula. Let me put on my sunnies because I can't see what the hell I'm doing. Alright. Famous Planck formula. This formula tells us the energy per unit volume per unit frequency for an electromagnetic field in equilibrium at temperature T. Why would someone confuse autism with bipolar disorder? Probably because they don't know enough to be able to tell the difference between the two, which is most humans, in all fairness, and I don't think it's their fault. I think it's more people just don't know. Why would they? I mean, it's like asking me about, the mutation of DNA in a certain subspecies of primate. I mean, how would I know, right? So it's just lack of information. I don't think it's lack of intellectual capacity in most cases. They just think that they somehow deviate from the neurotypical spectrum, or what they deem to be neurotypical, to the point where they don't know what to call it. So they'll call it autism or just some blurry thing in the atmosphere. All right, so what does this equation tell us? It is the energy in a volume, right, per unit frequency, so per frequency, okay, for an electromagnetic field. Okay, electromagnetic field is the field via which the electromagnetic propagates, right? So like light, for example, is electromagnetic wave, okay, in equilibrium at temperature T. So at a certain temperature, what we have, it's starting to get really windy, I'm gonna have to go in soon. Damn you, freaking wind, causing me problems. All right, at a certain temperature, okay, this equation says that there should be a certain energy in a certain volume of a unit volume for a given frequency. Right? Which means that you would expect that the frequency would change, or there would be more of one frequency than another frequency if you change the temperature and stuff like that. And that is brilliant, because that allows us as humans to then figure out, well, based upon what frequencies we're getting from space, we can figure out what temperatures stars are, etc., like that. But we can also figure out on a quantum level that if something has a certain amount of a wavelength, what temperature it should be. And you can actually figure out how the temperature will fluctuate for each individual quantum particle, which the temperature on a quantum level actually doesn't mean anything compared to what we think it means in real life at our level. What it means at that point, it has to do with the probability of the amount of places that the quantum particle can move and its degrees of freedom, which I won't talk about in this lecture. It's a bit too complex, but it becomes more like a computer program what temperature is. Actually, that's sort of, when you look at quantum mechanics, it's more like, it is like dealing with a software program, the software program of our universe. I guess that's one way to look at it. So what we're going to do now mathematically is we are going to discover, okay, the energy density in wavelength form. And that means that the wavelength density given a certain black body with a certain temperature. And that means that only a certain energy density can fit in that given black body, right? Which is, you could call it something that's able to have radiation inside it which can't get out. Let's just call it that for now. Like you could, maybe with a little gap. You could even call a star a black body if you wanted it, for all intents and purposes, right? So the question, this was a weird question. This is what actually started a lot of the quantum mechanics, 120 years ago, because the laws of original classical physics sort of showed that if light can get into something, then it should keep bouncing around and then getting hotter and hotter and hotter, then the thing just melts. But why doesn't that happen? Because all of us then should just decay and melt into nothing, and that doesn't happen. And it doesn't happen because we, for all intents and purposes, live in a software created in a software program. So it does not physically allow certain energies to manifest. That's it. So it's just that the rules at a quantum level say that, whoops, you can't have that temperature, so it's not going to happen. That's like, how weird is that? It's like saying, I don't know, Bose, you can't go through that door, so it doesn't matter how much I push you, you're just not going to go in, just because the law says you can't. So you just won't go in. It's the weirdest freaking phenomenon. Anyway, so let's do the equation. Now, we know, I don't know if you guys can see this, but we know, for example, that W, I'll show you what W is, omega, equals 2 pi c over lambda. All right, so what does that mean? That means, if you can actually see what's going on, the 2 pi is obviously 360 degrees. Awesome. And c is the speed of light, and lambda is the wavelength, and that's what creates this angular frequency thing. So that's basically just a frequency. Like, we know that frequency is like v over lambda, I think it is, or something like that, or lambda on v, I can't remember. That's like the classical interpretation, right? So now we're going to get the dw, because we want to get from dw d lambda, right? So we're going to derive both sides. This is where you need advanced high school calculus. So therefore this implies that the derivative of omega is the same as the derivative with respect to lambda on this side. Has it gone out of focus again, that piece of shit? I don't know why it does that. I still haven't figured that out. Periscope, man. Alright, so dw, and let's derive this side, which will be 2 pi c and minus lambda squared. So it'll be minus 2 pi c over lambda squared d lambda. Alright, so in other words, the derivative of omega, in other words, the analogy of speed of this frequency is the same as the analogy of speed of the wavelength multiplied by negative 2 pi c, which is 360 degrees by the speed of light, over the wavelength squared. Alright, and that's just basic high school derivative calculus. Now, if you guys keep having problems seeing this, I'm going to have to end this scope, because I've only got 2 people here anyway. But we'll do it anyway. It's all good. Bless you, Mum. Alright, so now we get Planck's formula, which is up here. Okay. And what we're going to do is we are going to chuck this into this. Yeah, I've only got 2 people. I might come back and do this another time, because it's clearly not entertaining anyone. But I love that you're here, guys, and always remember at Gapversity that facts don't care about our feelings.